Something is living on Mars right now. Not fossilized, not theorized, alive, and it has been enduring the very thing we spent decades calling the planet's ultimate death sentence. For decades, we looked at Mars and called it a killing field. A stripped, naked world. No atmosphere, no magnetic field. Completely defenseless against the cosmic fire of radiation pouring in from every direction. We firmly believed that nothing could survive there. But there is a strange coincidence. The organism that completely shatters this assumption is sitting right here on Earth, inside an irradiated can of meat from 1956 in Oregon. This tiny bacterium did not merely survive, it has engineered the most sophisticated DNA repair system ever documented in the universe. A perfect biological weapon, which scientists believe was originally evolved to sleep beneath the Martian soil for hundreds of millions of years. Its name is Deinococcus radiodurans, better known by its nickname, Conan the Bacterium. In December 2024, a breakthrough study finally cracked the question that had haunted astrobiology for 3 decades. How can this organism remain virtually immortal against the white death of radiation? And today, we are going to follow that secret all the way to Mars. Let us get the numbers down honestly, because this audience deserves real facts before anything else. Since 2012, NASA's Curiosity rover has been measuring a silent threat on the Martian surface: radiation. To put it simply, Mars is hit with 40 to 50 times the daily radiation we experience on Earth. What does that actually mean? Think of a living organism as a supercomputer and its DNA as the core operating code. High-energy cosmic rays are like non-stop digital glitches, constantly deleting lines of that code. If the system loses a few lines, it can patch itself. But when thousands of errors corrupt the system faster than it can reboot, the entire software simply crashes. Mars's atmosphere, 1% as dense as ours, thinner than the air at the summit of Mount Everest, stops almost none of this. The planet lost its global magnetic shield billions of years ago when its molten iron core cooled solid. It stands completely naked before the cosmos. The engineers at Johnson Space Center have calculated that a round-trip mission to Mars would expose an astronaut to approximately 60% of the career radiation dose limit NASA recommends, before that person even sets foot on the surface. For reference, NASA's Juno spacecraft, orbiting Jupiter in its own radiation hell, was built with a special titanium vault weighing nearly 200 pounds just to protect its onboard computer. Even so, Juno operates against a clock, completing science before cumulative damage becomes irreversible. On Mars, there is no vault, there is only depth underground and rock. For decades, this was the closed case. Mars is lethally irradiated. Life requires protection. Mars offers none. Then someone actually measured what Conan the Bacterium could handle. If we could achieve this breakthrough in our research, we could absolutely live on Mars. And here is the number that stopped the planetary science community cold. In normal, active conditions, Deinococcus radiodurans can handle a radiation load of 25,000 grays. To put that in perspective, a mere fraction of that amount, just 5 grays, completely overwhelms the strongest defenses of any complex living creature on Earth. Conan the Bacterium faces 5,000 times that limit and simply shrugs. When the research team at USU dried and froze the bacterium, mimicking frozen Martian subsurface conditions, its radiation tolerance jumped to 140,000 grays. That is 28,000 times the lethal human dose. The peer-reviewed calculations now standing in the literature follow from that number directly. A colony of these organisms buried just 2 to 3 meters below the Martian surface could theoretically persist through hundreds of millions of years of continuous radiation bombardment in a dormant, frozen state, breathing slowly in the dark while the cosmos fires down above them. How? The chemists at Northwestern, led by Bridget Hoffman, cracked the mechanism in the December 2024 paper. The answer is elegant, the way the best biological solutions always are. Most organisms die from radiation not because their DNA is destroyed, but because the protein repair machinery that would fix the DNA is also destroyed. Once the repair crew is dead, the instruction manual stays shredded forever. Deinococcus radiodurans solve this with a 3-part molecular shield, a complex of manganese ions, phosphate, and a small peptide that accumulates inside its cells in enormous quantities. Here is the image. Picture your home after a tornado has torn through it. Walls blown in, furniture scattered across 3 counties. Total devastation. But somehow, in the basement, your toolbox survived. Every hammer, every nail, every level, completely intact. Because the tools are there, you can rebuild, even from near total destruction, if the means of restoration were shielded when everything else was not. That is what the manganese complex does. Radiation tears Conan's DNA into hundreds of fragments. But the manganese shield protects the repair enzymes. The tools survive, and within hours, those enzymes reassemble the genetic code from the fragments, like a master craftsman working from a blueprint memorized over billions of years, until the DNA is whole and the cell is functional again. The researchers confirmed a direct correlation. More manganese antioxidant accumulation means more radiation resistance. Deinococcus radiodurans accumulates more of it than anything else science has ever measured. If the cosmos spent billions of years forging a DNA repair system this flawless, what is it trying to teach us? Biological armor. This powerful is not born in gentle places. It is the product of a 4 billion year selection pressure, where only the most resilient are permitted to exist. For decades, we assumed that building a permanent human colony on Mars was mathematically impossible because of radiation. But recent data has flipped that assumption completely on its head. We now know that the blueprint for enduring Mars doesn't require heavy, unrealistic steel walls. It requires biological adaptation. We don't conquer Mars by fighting it. We conquer Mars by learning how to become part of it. This changes how we look at our entire history of exploration. Think about the Opportunity rover. The engineers at JPL designed it to last just 90 days. It defied the odds and endured for 15 incredible years, alone on a brutal world, driving across ancient dry lake beds, outlasting every expectation by 60 times over. But in June of 2018, a global dust storm choked out the sun, and Opportunity's clock finally ran out. Its last broken signal home was translated as, "My battery is low and it's getting dark." Engineers who had dedicated their youth to that machine wept openly. Because on Mars, when your system crashes, there is no one there to reboot it. But Opportunity and the secrets sleeping beneath the Martian soil are, at the deepest level, the exact same story. It is the story of continuous reconstruction when everything around you is breaking down. The only difference is that opportunity's clock stopped. But the biological software we just discovered has been running without a glitch for hundreds of millions of years. By decoding how this system protects its core data using simple elements like manganese, chemists are already synthesizing advanced countermeasures for future Artemis crews, a drug designed to chemically reinforce human cells from the inside out. The teams at Johnson Space Center and Goddard are working toward a mission that will answer this definitively. Subsurface drilling, instruments designed to reach the depths where radiation flux drops to survivable levels, where ice deposits bring water into contact with ancient chemistry. That is where the next chapter of this story gets written. And the MDP compound that Northwestern's chemists synthesized from Conan's manganese shield is already being evaluated as a pharmaceutical countermeasure for astronauts. A drug that could harden human cells against the Martian radiation environment before the mission even launches. In a direct, unbroken line of cause and effect, the organism that may have seeded life on Earth is now being asked to protect the descendants of that life as they travel back to find out. The universe does not eliminate life in the face of extreme conditions. It compresses it, selects it, hones it, until what survives is something that the conditions themselves could not have produced without their own particular violence. You have lived long enough to understand that. You know what it means to absorb a damage load that seemed unsurvivable, to protect the tools inside yourself that do the rebuilding, and to come out the other side, not smaller, but more precise, more essential, more purely yourself. That is what Conan the Bacterium has been doing under the Martian surface in the frozen dark for hundreds of millions of years. We are small by every cosmic measure, a pale blue dot in a galaxy of 400 billion stars. But we are the only thing in this solar system, as far as we know, that looked at a naked, ancient, irradiated world and asked, what is still alive in there? And we built machines and now organisms to go find out. Now here is your question, and I want a real answer. If you were sitting on the mission planning committee at NASA today, would you vote to send humans to Mars in the next 10 years, knowing the radiation risk, knowing what is already waiting down there, or would you say another generation of preparation is owed first? Leave your position below, because the people making this decision are paying attention to what this generation thinks. You built the world that made perseverance possible. You have earned a say in what comes next. If you want to stay on the front lines of this cosmic journey and decode the secrets that rewrite human history, hit that subscribe button and turn on notifications. Your support is the fuel that keeps these deep dives going. Thank you for watching, and I will see you in the next video.